In the last video, we learned the definition of the cosine between two vectors. In fact, we pretty much derived this. So we said the cosine of the angle between two vectors is u dot v divided by the length of u times the length of v. So let's see what we can determine about two vectors when they're perpendicular. So if two vectors are perpendicular, what we say is they're orthogonal. So that's the word we use for perpendicular vectors. And let's see what we can determine. So u and v here. So this angle, of course, is pi over 2 or 90 degrees. And what does that mean? Well, by our definition of the angle between two vectors, that means that the cosine of pi over 2 is equal to this dot product. And while I'm writing this, think about what is the cosine of pi over 2? What is that equal to? We know what it is, it's just a number, right? Well, the cosine of pi over 2 is 0. So all three of these things are equal, and they're all equal to 0. Excuse me. So what does that tell us? Well, that tells us that u dot v must be equal to 0. So this implies that u dot v is equal to 0. And that's because the denominator here will never make this fraction 0. Okay, so if the vectors are orthogonal, then the dot product is 0. And in fact, that works in the other direction. If the dot product is 0, the vectors are orthogonal. So now we have a definition of orthogonal. Two vectors are orthogonal. So let me write this. Two vectors u and v are orthogonal if and only if. If you've never seen this before, this is shorthand notation for if and only if. Two vectors are u and v are orthogonal if and only if u dot v is equal to 0. So now we have a nice, easy way to test if two vectors are orthogonal. So let's take a look at that. So let's take two easy vectors with just two components and see what happens. So let's say u is equal to -3, 4, and v is equal to 4, 3. Well, let's do their dot product really quickly. U dot v is equal to -3 times 4, -3 times 4, plus 4 times 3. Well, it's pretty clear this is -12 plus 12, so that's 0. So by definition, these two vectors are orthogonal. So let's take a look at what they look like if we were to graph them. So u is -3, so we'll go over 3 up 4, -3, 4. So it's kind of a rough sketch. And then v is +4 and up 3, so about there. And even though this is just a rough sketch, it seems pretty reasonable that these two vectors are orthogonal. That looks to be about 90 degrees in there. And we know for certain, because this dot product is 0, we know for certain that they are orthogonal. And just by the sketch, that kind of confirms in our mind, if we had any doubt, that they are indeed orthogonal. Okay, so this is the definition of orthogonal. I'll see you in the next video.